So you've looked at linear equations, you've looked at quadratic equations. Now it's time to look at another two types, the cubic equation and the reciprocal. So the cubic, as the name suggests, looks like this. So if I try and plot that, when x is 0, y is going to be 0. When x is 1, y is going to be 1, because 1 times 1 times 1 equals 1. When x is 2, y is going to be 2 times 2 times 2, which is equal to 8. When x is 3, y is going to be 3 times 3 times 3, which is 27. So it goes up, as you can see, very quickly. When x is -1, then y is -1 times -1, which is 1, times -1, that gives us -1. So that's the other point. When x is -2, we go -2 times -2 times -2. These two make 4. 4 times -2 gives us -8. So -2, -8 is going to be there. So when x is -3, we get -27. So the graph looks something like this. So it has this kind of shape. And it crosses the origin. Sometimes it's wider, sometimes it's narrower. So if you had, for example, y equals 2x cubed, then you'd have to double the y. So for example, 1, 2 we'd have here, and then we'd have 2, 16. So it goes even more quickly. And then same thing on the other side, because this is mirrored. And similarly, if it was y equals 3x cubed, that would go even more quickly upwards. But if we had, for example, half x cubed, then we'd have to halve the answer. So when x is equal to 1, then y would be equal to half. When x is equal to 2, then we'd have 4. When x is equal to 4, we get 32. So this is a bit wider than the other ones we've just seen. So it gives you an idea. It's not perfectly drawn either. Or if we had, for example, y equals -x cubed. When x is 0, this is going to be 0. So again, as I said, all of them go through the origin. When x is equal to 1, then 1 cubed is going to be equal to 1. So y is equal to -1. 1, -1. When x is equal to 2, for example, 2 cubed is 8. So this is going to be -8. So 2, -8 here. And then when x is equal to 3, x cubed is 27. So this is going to be -27. So what do you notice? Let's do it on the other side. So when you've got -1, -1 cubed, that is -1, put the negative in front of the x cubed, so then we have +1. So -1, +1. When x is -2, then x cubed is going to be -8. So that gives us a +8. So -2, +8, and you can guess that it's going to be +27. So -3, +27. So as you can see, this has gone completely on the other side now. So the key things to remember is that it's rather than x squared or just x, this is x cubed. That's why we call it a cubic function. And the shape it has is either this or this side. Sometimes they go a bit more like this, or the same thing on the other side. However, at this level, it looks a bit more like this. Now we'll look at some reciprocal functions. So reciprocal, y equals 1 over x. That's what the equation of reciprocal looks like. So y equals 1 over 1 when x is equal to 1, and that gives us 1. So 1, 1 would be a point. When x is 2, then we get half. When x is 3, we get a third. So y is equal to a third. When x is 4, we get a quarter. So this goes down like this, so close to the x-axis, but it never touches it. And then on the other side, when you get x equals half, for example, then you get 1 over a half, which is like 1 times 2 over 1, and that gives us 2. Y is equal to 2. When x is equal to a third, then we have 1 over a third, which is 1 times 3 over 1, and that gives us 3. So that goes up to 3 there. When x is a quarter, then it goes up to 4, and so on. So it goes up like this as well, so close to the y-axis, but it never touches it. For x being negative, then this is just mirrored here, this quadrant. So it goes like this, getting closer and closer to the axis, but never touches it. So this is the kind of shape that a reciprocal function has. When x is negative, so y equals 1 over negative x, then that would give us 1, -1. So this is going to be repeated over here and in this quadrant as well. So it can be this shape as well, where this is the axis.